Hello, welcome to another section of Meet Math. Today we are having another headache problem to differentiate. But I believe most of you by now are familiar with how to solve problems of this nature because we have done one or two examples of this nature, so you know how to go by when you get problem of this nature if you are to differentiate. Anyway, I hope you guys are doing good. Where have you seen this problem before? Well, I don't know if you remember. In one of my videos, I integrated a particular problem, and this was the answer that I had to that integral question. And remember in that video, I said I'll be differentiating what we had at the end of that day, which was this. So here I am going to honor that promise. That is, I'm going to differentiate what I said I'll be doing. So we are going to solve this problem. But before we start, I can see some of you wish to pause the video and give it a try because they've already know how to go by with problems of this nature. Well, it's not a bad idea or it's not a bad feeling at all. You know, always believe in yourself, believe that you can do it, and probably at the end of the day, you'll be able to do it. We have to be always positive, always be positive. Don't, belittling yourself at don't belittling yourself always. No, sometimes you got to encourage yourself, say I'll do it, I can do it. Not just I'll do it, but I can do it, the can do spirit. Yeah. So why don't you pause the video and give it a try. Yeah, I hope some of you have done it and then they are just waiting for the solution to this question in order to compare theirs with date, and then they can decide whether to say, well, doesn't matter, next time I'll get it correct, or to jubilate, say yes, I got it. Yes. It's normal, students, sometimes when you get answers to a particular question, at the end of the day the teacher solve to confirm your answer, that kind of it boosts your morale, make you feel so good. So it's not bad at all, so well, since some of you are waiting to see the solution to this question, they are eager to see the solution to this question in order to compare it with their own, and then boost, yeah, let's compare with their own. Why don't we just get started? So let's get into the video. Let's write our solution first. Okay, so let's set this one be equal to y. So let's set y be equal to the whole of this. Okay, so let's write the equation. Okay, y is equal to 1 over 3 into bracket x squared plus 9 multiplied by square root of x squared plus 9 minus 9 multiplied by square root of x squared plus 9. Okay, I'm going to separate them into two. So I'll just differentiate this one alone and then also differentiate this one alone. I always say this. You can differentiate this one directly from here, dy over dx, and then just write down the answer for this one and also for this one. Yes, I can do that. I can do that. But if I do that, some of us, a lot, wouldn't be able to know how answer to this one what came by, and also to this one also what came by. Some of us will be able to understand, some of us will be able to know why answers to this one came by or how answers to this one and this one are gotten. But what about those who will not be able to figure it out? What should we do? Well, then the best way is to work out in bits so that it will benefit all of us. Okay, so we are going to call this one A and then call this one B, all because so that after differentiating this one and also this one, and we are putting back our answers together, when I say the answer for A, you know where you are going, and I say the answer for B, you know where you are going. So normally we give it, when it's like this, I prefer giving it an identity. After splitting them, I prefer giving it an identity so that when I mention a particular thing, you know where you are going. If I say A, you know where you are going, or you make where to find the answers for each of them what easily. Okay, so this one is A and then this one is B. So we are starting with what? A. We are starting with what? A. So differentiation of A. Differentiation of A. Let's set U be equal to A. Okay, so let's write the equation. U is equal to 1 over 3 into bracket x squared plus 9 multiplied by square root of x squared plus 9. Here we are going to do substitution. Substitution. You're going to let P be equal to x squared plus 9. This is so that we can know the derivative of what to this one also. Okay, so we will let P be equal to x squared plus 9. Now when you differentiate this, you're going to get dp is equal to 2x dx. 2x dx. Now that we know what is replacing x squared plus 9, which is p, why don't we put it back? So let's replace x squared plus 9 with p, and then we differentiate this original equation also. Now when we replace it, this is what we are going to get. U is equal to 1 over 3 multiplied by p times square root of what? P. Okay, this p can be written as p raised to the power 1 over 2. So you're going to get u is equal to 1 over 3 multiplied by p times p raised to the power half. Okay, here p is here and also p is here. The power of this one is 1 and this one is what? Half. And because p is here and p is also here and they are multiplying, it makes the base what? The same. The base of this half is p. The base of this power 1 is what? P. So the base are the same. And from the law of indices, from the product law of indices, when the base are the same and they are multiplying, we just add the exponent. Okay, so u will be equal to 1 over 3 multiplied by p. When you are adding the power, you just write one of the base. So multiply by p raised to the power 1 plus what? Half. 1 plus what? Half. Okay, so 1 plus half will give us what? 2 by 1 will give us 2 plus 1 give us 3. So 1 plus half will give us 3 out of 2, 3 out of 2. So u is equal to 1 over 3 times p raised to the power 3 out of 2. Now, I think this one is simple to differentiate as compared to this. Yeah, this one is simple. This one is more familiar. Is what we know. What we know. Sometimes, yeah, we find it difficult, interpreting this. Yeah, some of us, some of us. But this is what we know. When it's like this, we can easily solve as compared to this. All of them are easy, but some of us. So when you differentiate this, du is equal to this one will come and multiply this p, and then we decrease the power by what? 1. So du is equal to 1 over 3 times 3 out of 2 times p raised to the power 3 out of 2 minus 1 dp. Okay, so 1 over 3 times 3 out of 2. This and this will cancel out and to be left with what? 1 out of 2. Now when you come here, 3 out of 2 minus 1, 2 by this will give us 2, 3 minus 2 will give us what? 1. So we're going to get what? Half. So du will be equal to 1 over 2 multiplied by square root of p. Remember, p raised to the power half is the same as what? Square root of p. Just recall from here. This one was was written as what? This. So if you have gotten this somewhere here, there's nothing that should prevent you from writing it in this form. They are all the same. So du is equal to 1 over 2 times square root of p, dp. Now that we are done with the differentiation, what are we going to do? We have to go back to the x word. So what is going to replace this and what is going to replace this? Now let me write that one for you. P is equal to x squared plus 9, and dp is equal to 2x dx. So when we see dp, we will put this one there. When we see p, we will put x squared plus 9 there. So now that we know what is replacing them, why don't we put them back? Okay. Good. So here we are going to open the bracket. Now when you multiply this by this 2 and this 2 will cancel out. And then square root of x squared plus 9 times this one will give us x multiplied by square root of what? X squared plus 9 dx. So du is equal to x times square root of x squared plus 9 dx. So to get ds on the other side of the equation, let's multiply through by 1 over ds. If you multiply this one by 1 over ds, you're going to get du over dx. This one by 1 over ds, it will take away this dx. And so when 1 over ds take away this ds, we are going to get du over ds equal to x multiplied by x multiplied by square root of x squared plus 9. Okay, so this is the answer to the A part. Differentiation of it is what we have gotten for it at the end of the day. So let's move on to B. Differentiation of B. Okay, here we are not going to write set any blah blah, set any blah blah. We will just let m be equal to b, which is 9 multiplied by square root of x squared plus 9. We already know why we wrote set blah 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 to this, so there's no need for us to repeat it here because we have done it 1 or 2 times. So at least most of us, or at least most of us now know why we do it that way, so there's no need for us to reiterate it again. Okay, so here we're going to do substitution. Okay, t is equal to, let t be equal to x squared plus 9. Okay, dt will give us what? Dt will give us 2x dx, 2x dx, 2x dx. What is replacing x squared plus 9? That is t, so let's put t there. Okay, now to differentiate this, let's first rewrite square root of what? T. Let's first rewrite that one, and it can be written as t raised to the power 1 over 2. T raised to the power 1 over 2. Okay, so to differentiate this, this half will come and multiply this, and then we decrease it by 1, and that will give us t raised to the power 1 half minus 1, and that will give us minus half. And remember, from the negative index law of indices, t raised to the power minus half can be written as what? 1 over square root of what? T. So when we differentiate this, we are going to get dm is equal to 9 over 2 multiplied by square root of t dt. Okay. Now let's find what is going to replace this and that. Let me put that one also. T is equal to x squared plus 9, and dt is equal to 2x dx, 2x dx. So let's replace them. Okay, so here these two and these two will cancel out. Then 9 times x will give us what? 9x. And then when we multiply through by 1 over dx, you're gonna get dm is equal to dm over dx equal to 9x over square root of x squared plus 9. Now this is the answer for the b part, differentiation of what? B. So we are done with the differentiation, but we haven't gotten our answer. We have gotten our answers. You don't know what the marking scheme is going to award marks. The marking scheme can manipulate this answer further to get what? A particular answer. So to be on the safer side, just put your two answers together. Answer for A, answer for B, just put them together. Find out if you can add some, subtract some, eliminate some. And if you find out and you think it's possible, just do it and know what you are going to get at the end of the day. And make sure what you get at the end of the day, you can neither add or subtract, multiply or divide it. Okay, good. So let's put our two answers together. So add, put A and B together. When I say A, you know what I'm referring to, and I say B, you know what I'm referring to also. Okay, here dy over dx equal to du over ds plus dm over dx. You know, this one is representing the answer we had to A. This one also is representing the answer we had to what? B. You can bring the answer to A directly from here. You can also bring the answer to B directly from here without rewriting this one. They are all what? The same. Anyhow you do it, they are all what? The same. But here we chose to write dy over dx because we are done with the differentiation. You know, from the original equation, it was y is equal to something. What y was equated to was what y was equated to wasn't differentiated. So now that we are done with the differentiation, we have to see something which will tell us that the equation has been differentiated with respect to y and then x. So we shouldn't write y is equal to again, no, but rather we should write dy over dx because the equation has been what? Differentiated. And the moment we see dy over dx, everybody who know something about differentiation, you know that, oh, if it is not differential equation, or if it is not an original question where you are being asked to find the blah 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 of this, and it's a series of workings like this, and he sees something that he knows, oh, okay, the question has been differentiated, and then the derivative of that question is the what is going to be what added here. Okay, so yeah, what is going to be what added what here. Okay, so what is the answer to this one? This one was equated to something, this one also equated to something, so let's put them back. Let's replace this one with what was equated to, and this one also. So dy over dx is equal to sorry. Okay, now this one multiplied by this, here is plus, but remember from the original one it was minus. By here I said put it together. Put it together means we are adding, but we are adding, and here is the case, this one was what negative from the original what equation, though I did not attach the minus sign to it when I was differentiating the, but I did that I did it that way because I will put it the answer that I had to the original equation. I mean how it was being what formed. Okay, so when you come here, though this one is plus, this one I did this one this way because of what I wrote here. Put this and this together. So this one means we are putting it what together. When I say minus, you are not actually putting together, you are rather taking something away. So this one, when you apply this format here, it's like this plus minus this. Plus and minus will give you what minus at the end of the day. Okay, so now let's see if we can compute, or if we can divide or multiply or subtract some. Okay, the denominator for this one is this, and then the denominator for this one is what 1. This one is also 1. We can choose to rationalize this, and then we solve, or well, I'll not rationalize this one before we solve. What I'm going to do is I'm just going to, this one is the LCM, so I'm just going to multiply this one. So it's going to be this one times this minus this one. Okay, I'm going to write it as a single fraction by multiplying this one with this, and then we subtract 9s from it. It's the same thing as, no, the LCM will be, this one is 1. So when you pick the LCM as this, and then this one divided by 1 will give you the same thing. Multiply by this, is the same thing as that. Okay, so dy over dx will be equal to this times this minus 9x all over this one. Okay, good. Now when you multiply this by this, because this and this are the same, this is what you are going to get. You're going to get x into bracket square root of x squared plus 9 all squared, because it's 2. This and this, they are the same, so it's 2 minus 9x divided by x squared plus 9. Now square root of x squared plus 9 all squared, these two will take away this what square root sign. Okay, and it will be left with x into bracket x squared plus 9 minus 9x. Okay, so let's open the bracket. Dy over dx is equal to, when you multiply this, you're gonna get x cubed, and then this by this will give us what 9x minus 9x divided by what square root of x squared plus 9. Okay, so you see, if we hadn't done the computation, how will we got to know that we'll be able to what? Take away some. So at the end of the differentiation, make sure if there were lots involved that you maybe you differentiated separately, make sure you put your answers together. Okay, so you can see what I said is reflecting here. You see that after some one or two calculations, you could see that here we have gotten some like terms to be what? Eliminated. Okay, 9x, and then we also have a 9x. This one is positive and this one is minus, so this and this will cancel out. It has been eliminated and it's off. And what is left? X cubed divided by square root of x squared plus 9. So let me write that one down. You see, this and this has been cancelled out, and this is what is left: x cubed over square root of x squared plus 9. Now, can someone tell me what can be done to this apart from rationalization? What can you do to this? Absolutely nothing, with the exception of what? Rationalization. So this confirms what I said earlier on, that after your computation, make sure after your computation, whatever you get, there is absolutely nothing that you will do it again, maybe unless there was some set or radical that were involved that you wish to what? Rationalize it. Other than that, whatever you get as your final answer, there is nothing that you can do to it again. Subtract, probably you can divide, but this one we are not going to divide. If it is not where we are to find the value of, if it's not where we are to find the actual value, numerical value for this fraction here, there's no need for us to divide anything here. We don't have something like this here where we can also divide by cancel it out to be left with this one alone. But after the computation from here, this is what we have gotten. Okay, so if can someone tell me what can be done to this one again apart from rationalization? So that is the answer after the computation. So if you don't do the computation, how are you going to know that this is the answer that the examiner or your lecturer is what looking for? Okay, so we can add, we can subtract, though we can divide by. How are we going to divide? Unless we do rationalization, we are not finding any numerical value here. So what are you going to divide? X cubed divided by this. What are you going to write it down? Well, if we know the value for x, then we will just plug them into it, and then we just compute, and then we convert it to decimal. But that one is not required here. So you could see that what I said is what? Correct. Only if you are not to find maybe the actual value in terms of what? Numerals, in terms of what? Numbers. In terms of numbers. Let me say it that way. Because even if this, there is still one here, that one could have reflected here, where where that and this one could have cancelled before we reach what? This part. Okay, so this confirms that always after differentiation, make sure you check if you can add or subtract some in order to what? Figure out your final answer, or fish out your final answer. Okay, don't just differentiate and leave your answer like that. If you differentiate, if you neither cannot, maybe either add or subtract, whatever algebra aspect that is involved in your answer that you have gotten, maybe if it is simplified, make sure you do that one. It may be that out of that simplification is what you are going to get, or is where you are going to get your final answer. Okay, guys, have you seen that what we integrated in our previous video has been what gotten here? This is what we integrated in my previous video, and the answer we just differentiated is what we had. And after differentiating the answer, you can see that we have gotten the exact integral question. Well, yeah, I know some of you are happy because they were able to get the same answer. It's good. Keep on trying. You never give up. Never give up. Keep on practicing. Keep on practicing. Um, and I know you soon become expert in solving. When you just see the question and just look at it and say the answer to this question is just this, and it's like that. Sometimes when you are fan of thinking critically to solve particular problems in your heads, and when you do that for sometimes in some time to come, or later on when you see a problem, the moment you see it, your brain just begin to think, and just out of nowhere, come out with the answer. And some people say, hey, this guy the old whoa, but they don't know what you have been through to reach that stage. Okay, so guys, never give up. You just keep on practicing. Okay, so let's conclude. Therefore, the derivative of, this was the answer that we had. The derivative of this is equal to x cubed divided by square root of what? X squared plus 9. Yeah, I know what you are thinking. But well, that's it, guys. Well, please, if you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching.